Okay. Now, let me put on my headphones so everybody can hear me, right? I assume. Yeah, great. Awesome. Okay. Volume up, down. Okay. So, oh yeah, this is going to be chaotic. So who's already had class today? Anyone?
I had a class literally just less than 10 minutes ago.
And has it been a complete and utter chaos so far?
No, it actually worked out perfectly fine.
Excellent. That's good to know. All right. So let's go ahead and get started. So first off, we are looking for a peer note taker. We need somebody who is willing to share their notes with another student. This is through DRS. So if you would like, I put up an announcement yesterday. If you'd like to take notes for somebody else in this class, please let me know. All right. So now we need to get to the important thing about the first laser. I'm trying to teach. This is my kid. Sorry. So, you may not have been able to hear him because the microphone is very responsive to me being right next to me. But, all right. So this class, you know, right now we're online. We're probably going to resume in person, but everybody knows that's completely up into the air, right? They could totally decide, hey, we're online again. The good news for this class, at least, is that it just doesn't matter. This class is designed to be run in person. It's designed to be run online. It's designed to be run synchronously or asynchronously. This class just really, I've got this class down to being run in pretty much any modality that it needs to be run. So that's, I guess, good. This is because it is what we call a flipped classroom. So, and let me kind of demonstrate by opening up Canvas for you. So let me go ahead and see. Oh, I have a lot of more windows open than I thought I did. Okay, so, yep. Share screen and share specifically this over here. Okay, great. So we have this course that I've set up, and pretty much everything works through the modules, right? Here you've seen the home page, hopefully. If not, check it out. Click here to start at the very start of the modules. The other most important link is this one over here, where I'll be posting the recordings for not only this lecture, like the of what happens in class, but also like all the future, but also you can find all the lectures from previous semesters that I've done, in case you need some extra you know, resources. So be sure to check that out. But those are just simply if you miss the lecture or you need to review something that specifically happens in the lecture. You can find those here. Otherwise, most of your material is found here. Now, as I mentioned, this is a flipped classroom. That means that if you haven't checked out the information under Start Here, which I did a while ago, but still, it still applies, is that every lecture has a playlist associated. Sorry, every week has a playlist associated with it. It's 2 hours of it's about less than 2 hours of videos per week. It's basically all the material that we would be covering normally in a lecture. Okay, so it's all the material I would talk about normally, and you'd be spending your time being completely bored out of your mind in a lecture. Instead, it's split up into videos that are between 5 and 15 minutes long. Just depends on the topic. Like this video over here on for each loops, that shouldn't be too, here, let me open up on YouTube. Oh, now you decide to open up. Okay, that one's almost about 6 minutes long, so not too long. Now this first week's worth of material is essentially review. It's things that you should have learned in 1068, but if you haven't taken 1068 you know, if that was a couple semesters ago, right? And you need some review, or you feel like your skills have atrophied over the past couple weeks, then this might be worthwhile as to reviewing how inheritance works and how polymorphism works in general. But regardless, for all the other weeks, it's pretty straightforward. You click on the overview or the videos for that week, and they'll be there. They're also in my YouTube channel. Please note that this isn't one video, it's a playlist. So you'll either want to watch it on YouTube or click on this button here to sift through the videos. So, okay, I'm making you do lectures out of class. What are we going to be doing inside of class? For the most part, what we're going to be doing is we are going to be working on what's classically considered your homework. And the reason for this is that this first kind of, pedagogically speaking, the first exposure to material, which is typically when you have the most access to the professor, right? They're talking and then you ask them questions about the material they're going over. That's actually the least useful time to be meeting with your professor, right? That stuff, oh, I don't understand it. You can try to look at on that on your own as well. Or, you know, if the lectures are well done, then the questions should be minimal. The most useful time for a professor to have contact with the professor is when you're actually trying to do the harder tasks, which is like applying what you know. So like trying to do your homework. Our homework are essentially, so essentially our lecture time turns into additional lab time. Does that make sense to everybody? If you've taken me with 1051, you'll be much more, this should be familiar to you. However, what you should note, unlike 1051, there aren't a bunch of exercises. There's just essentially one big exercise a week and maybe a small quiz. Now these quizzes, don't worry about them. I'm trying to set them up so basically you have multiple attempts, if not unlimited. So, you know, they're basically did you understand the material, as opposed to please complete this so that you know this additional stressful thing you have to do. But you'll see is that we have one exercise a week. I'll probably be adjusting the due date since they were automatically imported, by the way. You know, they were imported from last semester and they've been automatically adjusted. So don't get too concerned about that. And again, if a due date seems too unreasonable, just let me know and I'll just move it. It's fine. Okay. All right. Does that make sense so far? So in class, what we'll be doing a bit of today after I help you get set up, you're going to be working on your assignments. If you have questions, you can ask me or you can ask the people in your breakout rooms, or once we're in person, you can, you know, flag me down or, you know, turn to the person next to you. I am very interested in making sure you can collaborate with your peers. In fact, for this assignment and for some other ones, you will be able to work directly with another person and turn in the exact same code as another person for this first assignment. Most of the time, it's, you know, got to be your own work. And I'll go into the details as to what I find unreasonable with code sharing versus unreasonable. But for this assignment, as well as some assignments later into the semester, you're more than welcome to work on with somebody else, and you both turn in the same assignment and get the same grade. Make sense? So this first assignment I will go over, but first let's cover the syllabus. So the syllabus is pretty extensive, so I'll go over the important bits because you know where it is. You found it. Great. All the labs are on Tuesday. And there are 2 sections for this class, by the way. Oh, sorry, 4 sections. 2 meeting at one time and 2 meeting at another time. So just simply go to the Zoom link of your appropriate section. I will be sending an email out for your lab sections because for our TA, one of our TAs is currently flying back from Serbia today. So, or tomorrow morning rather. So he'll not be able to proctor very well. So I'll be covering his lab for him. So, all right, if you haven't figured it out from the fact that you're online, you'll need a reliable laptop. If you don't have a if you cannot afford a computer, let me know. Because I need to help you find one that you can afford. Okay. That's not necessarily as hard as you might think it would be. A solution that will pull you through class will be somewhere between $200 to $400. Although with chip shortages, it may be closer to the $400 range these days. All right, if you've got a C in the prerequisite courses, you may need to work much harder, or you may need to consider retaking 1068. Just depending on what the reasons for why you got that C. Okay. Textbook. I'm not requiring it. The data structures textbook. It's a good textbook. It covers pretty much everything in the class. You can find all the slides for the class right here under files. And you'll see that there's a folder called slides, and it's got all the slides for the textbook. Okay. So that can help you there, but I'm not requiring the textbook. And the textbook was written by, 2 former professors, but honestly, I hate the textbook industry. I'm currently in the process of writing a new textbook for data structures, which I'll show at some point. One that will be free and open source. So, so that is the lengths to which I do not like having students having to pay for textbooks. So it's recommended, but not required. Office hours. I haven't figured out what my office hours are yet. I plan on doing so later today. So if you need to meet with me, just send me an email. But there is this very useful system I've got set up where you can either click this link right here or just keep scrolling down, and you'll be able to sign up for office hours over here. Just click here and click a time where a slot is a time or day where a slot is available. Once I have added my office hours, I will do that, and those might change once we go back in person. So, but you'll be able to see when there are slots, and it will send you a reminder when you have signed up, and we'll have some. The office hours will be conducted via Zoom because that is easiest for everybody. And right now we're still virtual. So, but even then, it's still safest right now to be to do those online. So no worries there. All right. Expectations for attendance, right? If we're in person and you feel sick, I don't care what kind of symptom it is, just stay home. I'll boot up Zoom for you to attend. Okay, if you're sick, I will boot up Zoom for you to attend. Just let me know that I need to boot up Zoom. Make sense? That's what the attendance policy comes down to. If you're feeling too unwell to participate, also let me know, and I will let you just watch the lecture in a bit. Mental health, right? So it's not like the times we're living through are super stressful or anything, right? Like there's no reason why anybody would have any mental health problems right now, right? All seriousness, it is actually very interesting times we're living in. If you are having issues, I will be happy to direct you to the right people. And even if you don't want that, I'm willing to be a pair of sympathetic ears. Academically speaking, for this class, the sooner you let me know you're having trouble, the sooner I can help you out, the sooner I can start making accommodations based on due dates and things like that. But I can only do that if you let me know. If you let me know like a week before finals, that is not exactly the best time. Make sense? Okay. If you have a disability or accommodation need, you should, if you've not done so, contact the Disability and Resource and Services in Ritter. Okay. Okay, grading, right. So in general, what happens is that the raw grades, any numbers you get are not curved. What gets curved at the end is the range of grades. So last semester, again, it was like 88 and above were A's. Actually, last semester was extremely good. I gave 1B and about 2/3 of the class made A's last semester. That was the first time that has happened. So either I'm doing something right or something terribly wrong. But it is as long as you keep up with the work, it'll be fun. By the way, the vast majority of the people got A's and very few people failed. There were more withdrawals than failures, and there weren't that many of them. So anyway, how do things how are your grades broken down? 5% of your grade is those just checkpoint quizzes, small quizzes, labs and assignments. So your weekly assignments that are done in lab and in the lecture, that's 35% of your grade. Worth equally amount are the 2 midterms that we'll be doing, one at around week 6 and one at around week 11. Those will be done in lab. They are electronic, so I will go into more detail about this, but as we get closer, but you'll have access to basically anything on your computer that is not speaking to other human beings. I think the way we did this last semester is that anything that was on your computer, on Canvas, or in your personal cloud was fair game. But going and searching on the internet was the cutoff point there. Does that make sense?
Are we allowed to use an IDE on the exams?
Yes, that's on your computer, and it's not talking to the internet. So yes, IDE. Yes, you're allowed to. Yeah, not only is it allowed, but you're encouraged. The exams will be in your labs. So unfortunately, that does mean 9 a.m., but that also means I give you the time to do it, the extra time that you have in lab. There will be 2 midterms, one at week 6, one at week 11, plus the final exam. So they will be in person if class is in person. So you'll be able to do them on your laptop or on the computer that school provides. However, right, things may change if we stay online. If they stay online, I'll have to change up the restrictions and requirements based off of that. But I try not to be too prohibitive about that. But at this point, we're beyond the questions of what does this code do? At this point, we are more along the lines of please answer these theoretical questions and please answer these questions that require you to code something. The final, and then we'll also have a final exam, which is its own thing. All told, the first exam is considered the roughest because, of course, that's during a very busy period when other midterms are generally given. Also, week 4 is the introduction of that is essentially our once you can get, if you can do week 4, you can do the rest of the semester. That's where we introduce linked lists, and you have to understand how reference it. You got to have, at that point, you have to have a good understanding of the way references work and objects work in Java. It's also the same way it will work in Python. The second exam, people do extremely well on if they've studied for it. It's a very good exam of testing whether or not you studied. And then the final, it's been, again, very good at determining whether or not you studied. Quizzes and exams, right? So, okay. So the big thing is that I have 2 separate late policies. Okay. All right. The 2 separate late policies are that late assignments, they have a penalty of 5 points per day. So they're worth 100 points generally. We take off 5 points for every day they're late, to a maximum penalty of 50 points. Okay. Does that make sense? So this is because I would like you to turn it in. even, you know, even if it's not for much credit. However, late assignments they are determined, your grade is determined when you turn it in, not when you demo it, which is the other thing you have to do. For every assignment that you do, you have to demo it. You have to show it to me or a TA. You can do this during the lecture. You can do it during the lab. You can do it during office hours. Okay. Demoing it. So it's a two-step process. You turn it in, that creates the paper trail to show that you actually did the assignment. And then demoing it, which is, well, what's the demoing? Well, you show me your code. I look through it. I ask you some questions, or the TA asks, or you can do this with the TA. You ask them questions, and they will just make sure that you did the code that you actually wrote, and that you understood the code that you actually wrote. If you are unable to explain it, the only penalty is that we tell you to go away and come back when you are able to explain it. So there's no real penalty. You have up to 2 weeks after the due date to demo your lab. Now, the reason for this is because we would often have students who would say, oh, I didn't know I had to demo my projects at the end of the semester, and try to demo all of them at once. And inevitably, we'd find that there was a minor mistake in each of them that prevented them from actually working. And that became a very painful experience because there was no time left to fix those things. So yeah, demo as soon as you're done. So, and if there's a mistake, we'll tell you to fix it. You fix it, no problem, no late penalty, right? Make sense? So now in general, we're lenient about those because if there's illnesses or other kinds of disruption, we can make accommodations for that. But just please don't, wait until the end of the semester. We'll just say no to demoing those. All right. We have a late policy for exams as well, because I know that those exams can take a long time sometimes, or you're still totally stressed out taking the exam. The late penalty is that it is a % of a point over the due date or the time limit. So like if you start the exam and you've spent 2 hours, the time limit on the exam is typically going to be 2 hours. If you go 2 hours, if you turn it in 2 hours and 2 minutes late, 2 minutes late, it will be 0.2% off. So if you've got a perfect score, you will have a 99.8. So 10 minutes late is when you lose a single point. An hour late, you lose 6 points. So if you need the extra time, it's there. You can take it. Okay. If you have an accommodation via DRS, ignore everything I just said. Okay. Make sense? So you can take you can take as much time on my exams as you need to take. Just be aware that after 2 hours, there will be a gradual penalty. Okay. Also, I know somebody dropped a group me in the chat. That's perfectly fine. I should just make you all aware that there is a Discord link that I have set up over here. The invite is found on the front page. It's for everybody in my class. There are people who've taken this class before who still hang around on the Discord. As well as the freshmen, they have their own channel, or the 1051 students have their own channel. Feel free to join that. I can answer questions on Discord very quickly. So it's another way of getting in contact with me. Also, a lot of times you can ask a question and a fellow student will be able to respond to that. So, you can set up your own side discussions and the like, but, this is just another way to reach out to me. And I know a lot of students use Discord. You do not have to use your actual name on Discord. So that also allows you to act in a pseudonymous kind of way. Okay. So, okay, let's see. Was there anything else? Right. Academic honesty. Don't cheat. For the love of God, please don't cheat. The only thing easier than cheating in computer science is detecting cheating in computer science. Pattern matching is literally a subdomain of our field of study. Don't cheat. My my total count for last semester was 47 charges submitted to students between all my classes. 37 of which were in the, I think about 37 of which were in the 1051 class. If nobody cheats, we won't be able to get to see your Reddit post. Fair enough. Fair enough. Don't worry. I assure you that people that there will be very impulsive freshmen who do not follow this advice. But let me go ahead and go through. First off, Chegg is just terrible. I've seen back last spring, when I, was doing these exams online and they were not really that well proctored. Some people submitted one of the questions online. Turns out the answers they got on Chegg were wrong. Chegg is not a good resource. Also, it doesn't help that they make all the same nonsensical mistakes and things. It's very easy to detect cheating via Chegg. I just have to wait a couple days for the internet results to populate. So just don't go with Chegg or Homework Helper or the like. It's really not in your interests. It's better in your interest, especially if you're having trouble on assignment, to reach out to me and say, hey, I need some help. Okay. So what is reasonable? In general, collaborating is encouraged. You can show your code to others when you're asking for help, but you can't view theirs if they've got a solution. Okay, that's kind of the way that it's doing. Oh, I need help. This code isn't working. Can somebody please take a look at my code and tell me why it isn't working? Awesome question. Perfectly okay. Please do that. Okay. Oh, no, hey, does anybody want to see my answer? No, please don't do that. So communicating with classmates, great. Helping somebody identify a bug in their code in person or online by viewing, compiling, running the code, even on your own computer, also good, right? Sending or showing you code that you've written to someone, possibly a classmate, so that they can help you fix a bug, provided you cite the help. So if you do work with somebody or somebody helps you with something, just in case that code ends up being, that section of code ends up being identical, because it might be a short piece that there's only like one really efficient way to do something, just cite it. Put in a comment that you worked with Alice Awesomeface or something. If you go on Stack Overflow and you find, like, again, how to do a few lines of your code, not the whole assignment, just like something like, oh my gosh, how do I sort a list or something like that? What's the easiest way to sort a list? Very common question. Right? Totally cool. Just put where you got it in a citation. In general, when you cite something, that's not gonna you're not gonna be referred to academic dishonesty. Actually, pretty much if you cite anything ever, I assure you I won't throw you to academic dishonesty. Sharing a few lines of your codes online, posting your few lines of yourself on Stack Overflow, so that doesn't work, so that somebody could help you. Also cool. Working with and paying a tutor, great, so long as they're not doing that for you. Whiteboarding the solutions, also cool. Or using diagrams or others, but not actual code, also cool. Not reasonable. Looking at somebody's answers before you submit your own. Don't do that. Asking somebody else for their questions. Sorry, asking somebody else for their solutions, also not cool. This is the big one. Failing to cite, as with comments, the origins of a code or techniques that you discover outside the course's own lessons and integrate them into your own work, even while respecting the policies of the constraints. So in other words, if you grab code online without citing it, that's a big no-no. Copying and pasting code you find from a site online, it's trivially easy to identify. Finding code online that addresses a question on the exam, and if you don't cite it, that would violate that policy. Finding code online that you think might address the question at hand and blindly copying it and paste it into the exam when it doesn't actually do that is a great way to make me angry and to get written up. I call out Chegg a lot because that's the source. Don't do that. If in doubt, I'm not gonna just in doubt, just email me and ask me if it's reasonable. Okay, you stumble across something on the internet and you're not sure if you can use it. I'll tell you. I'll be honest with you and tell you whether or not you can use that resource. Okay, if you're in doubt. Finally, I do have submitting the same or similar work for this course that you have submitted or will submit with to another without approval. That's basically if you're double dipping. That's not really relevant in here. Submitting after possibly modifying the work of another individual beyond the few lines allowed herein. So in other words, Bob grabs gets Carol's answers and then submits Carol's answers as Bob's answers. And all Bob did was change a few variables. That's easy to detect. Don't do that. So yeah, again, if you're unsure whether an action taken would violate the policy, it's better to ask. I can just tell you no, and that way you can just not do it. Otherwise, in general, if you committed some act that you're pretty sure you'd get written up for, and you realize, wait a sec, I'm probably going to get caught because Professor Rosen has a very good track record of catching people. There's a regret clause. Let me know within a TA within 72 hours. I might impose a 0 for that assignment on you, but I'm not gonna. But if you're honest with me and let me know, I will not forward you to the student conduct office. Make sense? Now, I don't mean to be such a strict guy about this. It's just that with the uptake, especially if we stay online, the temptation to cheat is just going to be that much greater. So if you're having trouble, you need more time, don't panic, don't search for an answer in a panic, email me. I might even be able to give you an accommodation and say, hey, you've got a couple extra days and I'll meet with you to help you get started on this. You'd be surprised how much further you can get just in 15 minutes. Make sense? All right, any questions before we actually get started with class material now? All right, so let's get started with class material because I like to do more than just go over the syllabus because now a lot of you took 1068 with Fiore, right? Professor Fiore, correct? Okay, is he still doing the online Java? Was it like, what, I forget, is it like Miore or something? Mimir, right? Okay. So everybody's had to install. Okay, great. Consistent answers. Awesome job, everybody. Okay, so everybody's had to install Java on their computer at some point, I guess then, right? All right, if you need a refresher on how to do that, I went over and over here, there's a module I put in, how to install Java in IntelliJ. If you have not installed Java yet, here's a video on how to do that. I used adoptopenjdk.org, but that has changed. The website has, it's now adoptium.net. If you go to adoptopenjdk.org, that will still work. Annie, it's very hard.
Laser, Daddy's teaching. Can you please not make that noise?
Sorry. Again, I don't know what you can hear and what you can't because the microphone is sensitive, but only like very close. I don't really care what you use, to be honest. Other than does it work for you? If it works for you, I don't really mind. I personally use IntelliJ because for Java, it's kind of just really well suited for IDEs like that. So anyway, if you need to reinstall Java for some reason, here's how to do it. And if you need to get set up with IntelliJ, here's a video on how to do that. As you can see, they recorded on 2 very different times. So the but I'll be using IntelliJ. If you don't like IntelliJ or Eclipse, my suggestions are, as Clayton mentioned, VS Code is just awesome in general. Atom's okay. VS Code's really good. Microsoft does really good job when they decide to push out open source software. They generally do a very good job with it. And then there's the two great granddaddies of code editing, which are Vim and Emacs. If you're using Vim and Emacs successfully, I generally will just kind of look at you and then realize, okay, this person's probably getting an A, because I've yet to find a student who's used Vim or Emacs and not gotten an A. Those editors are like, they're super powerful and you can use them basically anywhere on any computer. Unfortunately, they have a learning curve that looks like Niagara Falls. So, okay, let's go ahead and check out our first assignment then, since I don't necessarily have to walk you through that. But if you need to get walked through how to install Java, just click on that link over there. So the first assignment we'll do is actually a pretty fun assignment. It's called Fox and Rabbit. There's two things here we'll find. There's a PDF and a zip file. The zip file the PDF basically has everything I'm about to go over with you. It's a write-up for the assignment. There are a couple hints for it, but what we're going to do is that we are going to use this code. So give me a second and I'm going to, let's see, make sure there's nothing too embarrassing on my desktop. See, no, it's good. Yeah, I don't want you guys seeing my super secret plans for world domination. So, all right. So let me go ahead and share my screen. Okay. So over here, we're going to go ahead and I'm going to go ahead and create a new project in here. Next. And I'm going to just call it like Rabbit Hunt or Fox and Rabbit or whatever. Just going to name it whatever. Doesn't really matter when I name it. And now I've already downloaded this zip file. All right. Over here into my downloads folder. Okay. So what I'm going to do is I'll go ahead and extract all the files there. And I'm going to grab all these files. These are a bunch of Java files. I know, seeing like 9 Java files and saying, hey, this is your homework. Super intimidating. I know. Don't freak out. It's not that bad. So now watch what I'm doing. I took all these files, and this works on Mac as well, as long as you unzip the file. I'm taking them and dragging them, and see where I'm hovering over? The SRC folder. Everybody see that? Drop it into the SRC folder. That will move them there. Hit the refactor button. It works the same way in Eclipse, by the way. You'll want to drop them into the SRC file. Factor, and boom. Now it will associate all those with the project itself. Okay, and now I can go ahead, and what I'll do is I can stop sharing so that I can reshare. I could have just reshared, I know, so that we can just focus on this window. First off, would people like me to increase the font size? Because I don't mind. I actually like having my font size being kind of massive. I've just gotten so used to it for the purpose of doing this. One thing you will want to note. Okay. See, do we have Cascadia in here? No, I do not. So I'm going to just switch to Fira code, which is my preference. I'm a bit of a snob when it comes to fonts. And one of the things you'll see here is these. Okay, this is the first thing you need to note when you're working with code with me. I like to do this. This is my personal preference. I like to enable ligatures. So watch what happens to a lot of these symbols when I hit enable ligature. See this not equal? Pay attention to it. Okay. Is everybody able to see the pop-up box or no? Okay. Yeah, so I do that with ligatures, and what ligatures are is that in most programming languages, sorry, most fonts, right? If you have a F and an I next to each other, right? You might, if you check it out when you work in Times New Roman next time. If you have an F and an I next to each other in a serif-based font, what you're going to see is that to make it look nicer and fancier is the F will kind of overlap, the hanging top of the F will overlap with the dot of the I. Just try it out in like in a Word document and have it zoomed all the way up. And that's kind of the feature of ligatures, of just how you can tie multiple things together. Like if I had two T's together, the line in certain fonts will like merge together on the two sides of T's. So what programming literatures do is that they exploit this fact. So we would see so we can have a not sign and an equal sign, and they can come together into a not equals. Make sense? It's still two characters, right? It's just going to appear as a not equals. And I prefer that because that is more readable to me. You either like this feature or you hate it. I suppose you could also be completely agnostic towards it, and that's perfectly fine. But just be aware that's so if you see a not equals and you're wondering how in the world do you get the same symbol, it's just the not an equal. Okay, that's it. All right, so here we've got the project loaded up. There are two programs in here that have a main. This is the first one over here, which is Rabbit Hunt, the main, and you can identify it in IntelliJ by having the arrows, right? There's a little arrow icon over here. And here's grader. Grader is what assigns you your grade. Okay, let's go ahead and run Rabbit Hunt. I may need to share my screen, reshare my screen. Give me a second, because I don't think you can see this little screen that just popped up, right? A little window just popped up. I don't think you can see it, right? Okay, yep. Yeah, I just remembered that. Okay, now everybody can see my entire screen, so that should be no issue whatsoever. All right, so this is Rabbit Hunt. Let me go ahead and reset it. If you run this, by the way, for the first time, let me go ahead and stop it and rerun it. Just because the code is older, it does bug out the very first time you run it. Okay, and notice that it's completely blank. Don't worry about that. As soon as you hit run or step, it'll fix itself. So let's go ahead. So this is Rabbit Hunt. It is a simulation. The red dot represents a fox, a very, very hungry fox. And the brown dot represents a rabbit, a very, very stupid rabbit. The object of the game, as it is for the red dot, the rabbit. It wants to hunt down, sorry, the red dot, the fox. It wants to hunt down the rabbit. So the red fox wants to hunt down our rabbit. Okay, if it can do so within 100 turns, it wins. So notice here the turns, the steps going up. A turn is this guy goes and he goes. So see, oh, you might get a survivor for once. That's like super rare. Oh, too late. Nope. The fox eats the rabbit after 83 turns. So a turn is the fox goes and the rabbit goes. Make sense? So they each make one step along this grid. Maybe one day I'll rework it so that it uses the actual way to do things, which is hexagons, but oh well. Okay, because hexagons are the bestagons. Okay. Now, as you can see, the fox is very successfully hunting down and devouring this poor rabbit very consistently. Okay. So your objective is that you want to modify the rabbit's code so that it gets its survival, to up its survival rate. Your grade is actually directly proportionate to its survival rate. It's based off of what we call a square root curve. So the idea here is that we'll take your survival rates. Let's say your rabbit survives 81% of the time. Okay, what I do is that I'm going to take the square root of your survival rate and multiply it by 10. So an 81% survival rate gets you a 90, okay, for the survival rate on the game in terms of your grade. There are a maximum of 120 points. You get 20 points as a freebie for demoing, and then plus your survival rate. That helps kind of skew it. If you get a 64% survival rate, guess what? That's an 80. That's a grade of an 80 plus your 20. That brings you to 100 out of 120. You'll also note that this means that there are diminishing returns, by the way. So like once you get to 81, that gives you a 90, but to get to 91 requires a bit more effort, quite a bit more effort. So this is so again, it's what we have here. So what are the rules? Rule number 1, pretty much anything is allowed so long as it's done in rabbit class. Rabbit class is the only class you can modify. Sorry, it is the only thing you can modify with one exception. Okay, over here. So this is the only class you can modify. The only other thing you can modify is if you go over here to grader, is you can modify this variable, the number of trials. So what does the grader do? The grader is currently set up to run this program 300 times. So the rabbit escaped 2 times out of 300. So that way we don't have to watch, your game a bunch of times. This will just run it really quickly without popping up the window. And it says, hey, you survived 2 times out of 300 or 0% of the time. So your grade is 0, right? So it will automatically do the square root curve calculation. So if this says, hey, you got an 81%, this will come out as a 90. Make sense? All right. So this seems overwhelming because there's a whole lot of things. So let's first find out what we can ignore. We can ignore the grader. You can't modify it. You're not allowed to. And it just works on doing the game. So let's go ahead and ignore that for right now. We just know that's how we can run it to figure out what our grade would be. Okay. Why would you want to modify this? Because the more runs we do, the less luck is involved. Make sense? Right? Sometimes you might get lucky or unlucky. All right. So what about bush? It's very empty. Very interesting. Okay, so what do we actually have to, so let's take a look at our rabbit class. So our rabbit class is basically broken up into 2 things. It is a rabbit that extends animal, extends. That's an important word there, right? That establishes that there's an is-a relationship, right? Between the animal and that means that we've established that there's an is-a relationship between the rabbit and an animal. The rabbit is a animal. And if we look over here, and as we will do in a second, there's a whole lot of things that a rabbit can do because it's an animal. Okay. The other thing, as we can see, is that we're overriding a method in animal called decide move. Doesn't take any arguments, and it's we can pretty much figure out what it's supposed to do based off its name, which is that it decides what moves it's going to make. It's going to make a random move from the min direction to the max direction, which if we run our program again, that kind of makes sense, right? If we focus on the dot on our rabbit dot, it's moving randomly, right? It's just moving randomly. No care in the world. Now our fox, on the other hand, does not move quite at random. As soon as he sees the rabbit, he makes a beeline for it or its last known position. Otherwise, it paces back and forth on a straight line, and once it hits a dead end and can't keep pacing, it will basically choose another random direction to go pace in. You can actually look at the fox's code. It's right over here. It is, it's the side move. I would not recommend copying it and trying to reverse engineer it because this is predator code. Predator code is a lot more complicated than prey code needs to be. The prey, it just needs to run away. The predator code, it needs to do this. But it's useful looking around to see how it works. Now, a lot of the things it can do is because it's an animal, like over here. So here it starts out with a can see rabbit now variable. It's false. For int I is equal to model.min direction, I is less than or equal to model.max direction. So inclusively for the min direction and the max direction. What are those? Well, those are in the model class. And it's time that I talk about the model, view, and the controller. Okay. So we've got these 3 classes here, model, view, and controller. This is a very classical way of thinking about graphics, where you have an internal model that represents all the logic that's going on in the program. You've got a view, The view is, well, it's this graph over here. It's this stuff that we're seeing, right? This is the view, the playing board. This is the view. It's a representation of our internal model. And then we've got the controller, which is the slider affecting how fast the game goes, telling me whether I want to stop, resume, start a new board, right? And run it. That's our controller. Don't need to mess with that at all. Okay, so view and controller gone away now. Okay, so model. What's useful about model, though, is because it's the internal logic, it has a few things. The number of rows, the number of columns. And it has, so you don't have to remember that 0, you don't, so it also says that, hey, 0 is north, 1 is northeast, 2 is east, 3 is southeast, 4 is south, 5 is southwest. That's hard to remember. So you can just say model.n to get north, or model.southwest to say you want to do something in the southwest direction. Make sense so far? If you want to stay put, we just do model.stay, and I can show you that, right? If I just change this, return model.stay. So here, the rabbit's just going to stay put. Run. And you can see that the model is just, the rabbit is just staying put. And into the jaws of death. Okay, so what can we do here with our animal? So what can an animal do? Well, we saw that it can choose stuff at random. We can look, which tells me what it can see in a direction, as well as distance. We can see this with the fox and with the rabbit hunt class. So let's look at this. So can see rabbit now for model.min direction. Model is, I is less than model.max direction. So it's going to look from north all the way around clockwise. And then says, hey, if I can see the rabbit, mark that down and also mark the distance in that direction. So if looking in direction I is the rabbit, aha, I've seen the rabbit, update my internal logic accordingly. Now, rabbit don't need that. The rabbit just needs to, the rabbit can survive on a completely reactive basis, okay? The rabbit can survive on a completely reactive basis. Also notice that it's not bothering to like mention, okay, look north, then look south, and so on and so forth. It's just simply using I, right? If you end up having to make 8 cases, like, okay, if the fox is to the north, do this. If it's to the south, do this. That's just a lot of work. You want to avoid doing that. We'll go into that in a second. So here, right, what am I going to do? I'm going to do rabbit hunt again, and we can see the look in action if I hit step. And you can see that those yellow laser beam kind of come out of the fox. That's it looking. And notice something here, okay? And here I'm going to use my terrible MS Paint skills, okay? Right, it's looking in this direction and also this direction. And it will look in this direction and this direction. Those bushes, by the way, block movement and line of sight. You can't move into a bush, and you can't see through a bush. Right? So notice what's going on. So what am I trying to point out here? And I'll go ahead and use a nice thick pen with, let's go with purplish. Nah, that's not distinct enough. So this area, this black over here, that's a blind spot. Okay, these are giant cone-shaped blind spots that the fox can't see. It's vision. These computer vision isn't like our normal vision, right? It's just seeing in straight lines. So we have two strategies. There are two strategies that you can do. The first strategy is exploit the blind spots. Say, you are a rabbit. What should I do in this case? Well, moving backwards, that's a terrible move, right? Because you're still in the line of sight. The fox is going to chase you and eat you and hunt you down and eat you, right? But what if I were to move right over here? Movement is asynchronous, right? It goes, then I go. If my strategy is just wait until he moves, right? The fox will look, then he'll move. So it's quite possible for the fox to move, right? To look, not see me, then move, and then on the next turn he would see me. But I get the chance to look before he does because we're swapping turns, right? So if I move out of his line of sight, like to this spot right over here, he won't be able to see me. Awesome. That's strategy one, which is abuse the line of sight mechanics in this game, which is move out of his line. If I can see him, move. Otherwise, stay put. Okay, that is strategy number one. Strategy number two is much more ambitious and certainly harder, but some students like it. And for those of you familiar with any MMORPGs, the other strategy is to kite the fox, right? What does that mean? Well, one of the strategies in MMORPGs is when fighting an enemy, you just have one player basically run up to the monster, say, hey, look at me, come and attack me, you stupid monster. And then the monster chases after that player who proceeds to run while the rest of the party does stuff to the monster that doesn't gain aggro, doesn't draw the attention of the monster. Typically stuff like this is damage over time effects, things that slowly damage the monster, but don't immediately pull aggro. And kiting is certainly possible because you're running at the same speed, right? If it was faster than you, this would be silly. So one strategy, but ostensibly, like if you're at the same speed, as long as you know where you're going and can steer the fox properly, awesome. All right, so let's go ahead and get you just started briefly on this one. Okay. So the first thing you'll want to do is to look in every direction after this, right? So what we want to do is by default, I want to stay still. Otherwise, and this is for the exploiting line of sight strategy. For I, boom. You know, I love IntelliJ because of all those shortcuts. All I did was for I hit tab and boom, it was already there. Model.min direction, model dot max direction. We want to be inclusive, so equal to sign there. And then we'll say if look in direction I is equal to model, and I'm going off of memory here as well as the fact that I've done this 1.5 million times, right? So it was like, hey, if I look and I see a rabbit, awesome. Go, I found a rabbit here. So obviously we would do model dot fox. In this case, I need to do something here. What would I want? And this is really all the logic you need. So now that I've seen the fox and determined he's in direction I, what do I need to do? I need to move accordingly, right? Now, how can I do that? Well, the key to making your job easy lies in this single function over here in model. If I can spell it correctly, that's always a tricky proposition, right? Which is model.turn. Okay. So model.turn, given a direction and a number, turns that amount. So it allows you to figure out kind of relative directions to each other. All right. What does that mean? And where did I mess something up? Oh, it's not there.
I'm gonna go down.
All right. So model.turn, you can see it being used, by the way, over here in this, where basically if the fox is saying, hey, if there's an obstacle in the way, I'm going to try to step to the right and then try to step to the left around it. relatively speaking. So what does that mean? Okay, so suppose this is directions, this is direction facing towards the camera. Me is direction, okay? Okay, so it takes in two things. If I give it direction and 0, and let me go ahead and be a little silly here. Okay, which is okay. And let me go ahead and pin my video, right? So this is direction and 0. If I do model.turn direction and 1, it's 45 degrees counterclockwise from the original direction. So now I'm facing this way. 2 would be this way. So if the fox is in direction, this would be saying move to the right. The fox is in this direction, move to the right. Model.3. This is model.turn direction and 3. Model.turn and direction 4 is directly away. 5 is away and to the left. 6 would be to the left, right? And 7 would be going towards it and to the left. So you don't actually have to know north, south, east, west. Everything is relative to the direction, which would be I in this case, the direction to the fox. So, so that is my hint to you to get started. So for the remaining amount of time in class, you can go ahead and get started on this, try to get it working. I know that's only 20 minutes, but I will be there on give me a second. I will be there in the labs, and your TAs will be there on the labs, and the TAs have all been in class. Sorry, they've all TA'd, both the TAs, both Jovan and Bill, they have TA'd for me in the past, so they both know all their stuff. So this is what you want to use, model.turn. You can see how it works in the Fox class over here. And I don't want to give you too much of an answer, because once you understand it, it's like, oh, that's super simple. Okay. So what you need to know is not necessarily how this code works, just understand what it does. Given a direction and a number of times to make a 1/8 turn clockwise, return the resultant direction. And you can see it being used here. So I will stop. Sorry, I will turn off my. So here's what I'm going to do. Because there isn't too much time for you to work yourself on it. What I'm going to do is I think if you want to go for the day, you can. And if you want to stay behind and get to work on this, or if you have questions about it or installing Java or whatever, I'll be happy to answer them. Make sense? So return to meeting, and so stop recording.